हेलो एवरीवन, वेलकम टू अनदर लाइव सेशन ऑन जीके। और आज हम कंटिन्यू करेंगे ज्योग्राफी पढ़ना। तो लास्ट क्लास से आगे बढ़ते हैं। फर्स्ट सम बेसिक्स। रिमेंबर दैट ज्योग्राफी is made of these terms geo and graphian, meaning measurement of earth, measurement of the geo, that is earth, physical यानी कि physical features। जब हम मैप्स देखते हैं, ज्योग्राफी पढ़ने के लिए बहुत जरूरी है कि आप लोग मैप्स, जो एटलस रखी है आपके पास, उसको खोलें, उसको पलट के देखें। इट इज एन अमेजिंग रिसोर्स। और रादर देन जस्ट क्रैमिंग फैक्ट्स, आप विजुअल मेमोरी के थ्रू अप्रोच कर सकते हैं इस सब्जेक्ट को। नॉट जस्ट ऑफ प्लेसेस बट ऑल्सो मेनी अदर जियो इंफॉर्मेटिक्स मैप्स, जैसे कि नेशनल पार्क्स, वाइल्ड लाइफ सैंक्चुरीज, प्रेशर जोन्स, हाई प्रेशर जोन्स, लो प्रेशर जोन्स, ये सारे डिटेल्स एक एटलस में दिए होते हैं। एंड इट इज वेरी इंपॉर्टेंट दैट यू स्टार्ट यूटिलाइजिंग योर विजुअल मेमोरी एंड लर्न ज्योग्राफी थ्रू मैप्स। After we finish this class, I'm going to give you some tasks regarding looking at maps. Kindly do that in order to consolidate whatever knowledge we are going to learn here. So physical features, when you see maps, there are two kinds of maps. One is the physical map, the other one is political maps. Political map, political map which comprises political boundaries. Political boundaries. These boundaries are not drawn by nature, rather they are drawn for administrative purposes. And the physical features include mountains, rivers, deserts, lakes, plateaus. These are called the physical features of any map or physical features of any geographical area. Moving ahead, so last time we had covered other spheres. Today we reach the atmosphere, और एक एटमॉस्फेयर का क्लासिफिकेशन, उसके लेयर्स का डिस्क्रिप्शन. सो इफ दिस इज द अर्थ, देन this is the first layer is the troposphere, and it is the troposphere where 75% of atmospheric gases are contained. This is one thing. And all the weather phenomenon, all weather phenomenon all weather phenomena occurs in troposphere. What are these phenomena? These are rain, storm, cloud formation, so all of these occur in the troposphere. The extent of this troposphere, let's say if this is the equator and here lies the pole, then the troposphere goes something like this. So its extent over the equators will be 17 to 18 kilometers, or you could say 16 to 18 kilometers, whereas पोल्स के ऊपर इसका एक्सटेंट होता है 6 to 7 kilometers only. This is one thing. Then tropopause, the layer where this troposphere comes to an end is called the tropopause. Once we finish knowing about all the layers, let's see why this pause occurs and what are the characteristics of various layers of atmosphere. But first, let's get to know the nomenclature of these different layers of the atmosphere. Then there is the stratosphere. Stratosphere, its average extent from 10 kilometers to 30 kilometers, and it extends up to 50 kilometers. This layer is defined by absorption of UV by ozone. So, if I were to draw a temperature profile of different layers of the atmosphere, then that temperature profile would look something like a rotated M. So if this is the height, so, and let's say this was somewhere around 30, 50 degrees Celsius. So what happens? What occurs? So what actually happens is that you all must know that as we go up a mountain or as we go up in terms of altitude, as we ascend, the temperature goes on reducing. So in the troposphere, the temperature goes on progressively reducing, and it reduces at this environmental lapse rate, which is 6.8 degrees Celsius per किलोमीटर. यानी कि 1 किलोमीटर अगर हम यहां से ऊपर जाएं, let's say presently I'm standing in Delhi, and if I go 1 kilometer above, then the temperature, if presently it is, let's say 30 degrees Celsius, then 1 kilometer above the temperature will be 23.2 degrees Celsius. So that is the environmental lapse rate, the rate at which temperature reduces as you go up. But this process occurs, this phenomenon is observed only in the troposphere. As we know that the stratosphere contains ozone, so this ozone, its structure is O3, and how it is formed is that this oxygen molecule, which has bond between it, this absorbs ultraviolet radiation. So you must have heard the term at least endothermic reactions and exothermic reactions. Some reactions they require heat, some reaction they give off heat, like let's say for example burning or burning of hydrogen gas, H2 gas. When ignited, then it burns with the combustion occurs with a blast and H2O is formed. So this is an exothermic reaction. Or you can do this experiment at home. If you have a thermometer, you have a bowl, and you have salt, common salt, sodium chloride, table salt, common salt. If you add it in water, if you mix, let's say 5 tablespoons of salt in water, then you will see that the temperature of that water increases because this bond breaks and it releases a lot of heat. So what occurs over here is that normal oxygen molecules, they undergo a breakdown by absorbing UV radiations, which are very highly energetic, and then this combines with another oxygen molecule to form ozone molecule. This ozone molecule, it's not healthy, it's very unhealthy for human breathing, and if anyone were to inhale ozone, then it would lead to asphyxia or suffocation. The disease, the problem that occurs that you would see if you were to inhale ozone would be asphyxia. And it can lead to death if one were to inhale a lot of ozone, then it could even lead to death. Asphyxia is the disease, is the condition, is the situation observed in people who inhale oxygen and ozone. And it is also this ozone that helps in the formation of photochemical smog. Smog is smoke. It's a term, it's a portmanteau made of smoke plus fog. Fog, water particles, smoke, soot particles, they together make this photochemical smog, which contains other volatile organic compounds. And this occurs when there is temperature inversion. We will see what this temperature inversion is, but it will be, remember, it will be closely related to this phenomenon where temperature decreases as you go up in the troposphere. Now, since this oxygen is absorbing all of that UV radiation, imagine where will that energy go? In the case of water, when liquid water is made to boil, then that heat is contained in this steam. That heat is absorbed by this steam, by the water, and it gets converted into steam. The liquid water gets converted into steam after absorbing a lot of heat. So, similarly, by this analogy, you must understand that whatever UV radiation is being absorbed, its energy gets transferred to these molecules. And that is why you will see that rather than decreasing, the temperature again begins to increase. It is because of absorption of ultraviolet radiation by ozone molecules or oxygen molecules and ozone molecules that its temperature, the temperature of stratosphere, begins to increase. Then again, after 50 kilometers, you will see it extends up to 50 kilometers. Again, you will observe that the temperature begins to decrease, and as you reach the thermosphere, again temperature will increase. So what I told you, it is a rotated M shape. Such a temperature pattern is displayed by the atmosphere. And as you can see here, the point where stratosphere comes to an end is known as mesopause. Mesopause, that means the layer where mesosphere begins. Then thermosphere, from 50 to 400 kilometers is the presence, or the layer is called thermosphere, which also contains ionosphere. This ionosphere begins above the height of 80 kilometers, and there is intense absorption of energetic ultraviolet as well as X-ray radiations from the sun. That is why you would see that from here on above 80 kilometers, again the temperature begins to increase. Why does it increase? Because there is absorption of UV and X-rays. UV or ultraviolet, or the region, the section of that part of the spectrum of light from the sun which is above violet color. This is the spectrum of visible light: violet, indigo, blue, green, yellow, orange, and red. And as I have explained in the previous class, let's take a look at it in the next slide. We will need it. So frequency and wavelength if you were to map both these qualities, then violet would have the highest frequency and lowest wavelength, and this wavelength will increase in this order and the frequency increases in this order. That means out of all these frequencies, red has the highest wavelength and violet has the lowest wavelength, highest frequency, and this will have the lowest, red will have the lowest frequency. You must understand this. It is very important to understand all further concepts. So please make sure that you do understand this. Now, the importance of ionosphere. Ionosphere is a very important layer. Now you see, Earth is a big sphere compared to our size, human size, or even compared to what size buildings are. So there is one form of communication which is known as line of sight communication, LOS. This is also known as LOS communication. But as you can see, that line of sight communication cannot occur beyond a certain point. It cannot occur. So what scientists discovered was that there exist ions or charged particles. And these charged particles present in the ionosphere, they reflect back these radio frequencies. Because they are radio frequencies, they are lower in energy, they are reflected, and that is how radio communication becomes possible. So had this ionosphere not existed, radio communication would not have been possible. Yes, satellite communication would still have been possible, but this radio communication, this critical communication technology would not have been possible. Then we come to the exosphere. So generally, there is no clear or sharp boundary between atmosphere and the space. There is a gradual change after exosphere where atoms are arranged according to their molecular weight. So whatever atoms remain, they are arranged in layers, and that is how finally the atmosphere ends. One important GK fact that you must know is that a line has been defined known as the Kármán line. Kármán line, this is important to know. It has been defined. It does not exist as a physical feature. It is not a nature defined boundary, but we define it, and it is this line beyond which space begins. Space begins. Kármán line. Please note it down. You must remember, just like sea level, it is an average, it is a mean, because the height of the sea at different places also varies because of tidal effect. Sometimes it increases and sometimes it decreases according to whether there is spring tide or neap tide. The effect of sun and moon together make the water portion bulge. That is the reason for tides. And so depending on these situations, there can be variation in the sea level height. Similarly, there is this Kármán line. Above it, there is space, and below it is the atmosphere. A related term, a related fact that you should know is that the Gaganyaan, India's manned space flight, I'm giving you this example so that you may understand that there is no sharply defined boundary of where the space begins, and we intend to send this up to 400 kilometers in orbit with a crew of 4 members. Now, it would be my request to you to type it out in the comment box. Who are the members of this crew? They are 4 pilots of the Indian Air Force, and I want you to type their name because it becomes very important for the upcoming exams. India's first manned space flight, and the crew that is going to go, that is going to be a part of that. It will be a historic moment, and these people are going to be part of history. So it is a very much expected question in any of the exams. Please do find it out, type it in the comment section. All right, so this was an introduction of the layers of atmosphere, the composition of atmosphere. Now, another important concept, very fundamental to your understanding, is the concept of insolation and heating. Now imagine if the atmosphere were to be heated from the outside, if it was beginning to get hot from the outer layers of the atmosphere, then the effect that we saw of reducing temperature would not have existed in the case of troposphere. In the case of exosphere, I agree that whatever temperature is there, it is because of the intense absorption of those energetic rays from the sun. But in case of the lower layers of the atmosphere, what actually happens is that the earth receives all of the radiation in terms of short wave radiation. Short wave means high frequency, and therefore short wave radiation, because sun, it's a very hot ball of fire and it emits high energy rays. High energy, the energy content of those rays is quite high because it has X-rays, UV rays, gamma rays, visible light, and infrared as well. But since these rays are energetic, we call them short wave radiation. And this short wave radiation heats up the earth. The layers of atmosphere are in turn heated by the earth. They are not directly heated by the sun rays, rather they are heated by the heat of earth. The earth radiating back heat to space. That is how the layers of atmosphere are heated. That is why down below you have temperature equivalent to what is the temperature near Earth's surface. And as you keep going up, the absorption decreases, the molecules present in the air, the atmosphere becomes thinner, or we call it rarer. So it is because of this effect that temperature drops, because absorption by these molecules themselves go on decreasing in number, and therefore the absorption of what the earth radiates back long wave radiations. Long wave, that means the wavelength is long, the frequency is low, frequency is less frequency means less energy, because sun is not a direct source of light or heat, rather it is a passive source of light or heat, passive source of heat. Of course, light, the Voyager spacecraft took a picture which is known as the pale blue dot. It took this picture from beyond the solar system, from beyond Pluto, and that gives us a perspective of how really tiny our existence is in this vast cosmos. So that was a perspective giving picture. Remember, it was by the Voyager spacecraft sent by NASA, which took this very famous picture known as the pale blue dot. This pale blue dot is nothing else but Earth. So remember this concept that the Earth is heated by sun's rays and the atmosphere is in turn heated by Earth radiating all the heat it has absorbed during the day. Now, here is some data regarding how much heat is emitted by the sun, how much insolation comes at the boundary, and how much is radiated back. So 6% is already scattered and returned to space by the atmosphere. Scattering means the deflection of electromagnetic radiation, the rays that approach. So molecules present in the atmosphere already scatter it. They send it back to space. Out of whatever insolation, incoming solar radiation. Insolation means incoming solar radiation. Incoming solar radiation. Then 21% is scattered and reflected by clouds. You will see that at least 30 to 40% of the Earth's area, if you take a satellite image, you will always see clouds, and a majority portion of the radiation, 21%, is reflected back by the clouds. 18% is then temporarily absorbed by the atmosphere and clouds before being sent back to space. Now these clouds, they are made up of water droplets, and water droplets, as you know, they can absorb heat. Water itself can absorb heat, and you must also know that water has the highest specific heat. There is no liquid like water because it has the highest specific heat. It is a universal solvent, be it a polar substance or ionic substance. Water dissolves everything. Eventually, water is a universal solvent. Water has a triple point. You must know these details about water. Triple point. Triple point of water is 0 degrees Celsius. Triple point means that point of temperature, that point on the thermometer where water can exist in all three states: solid, liquid, and gas. It might seem perplexing to you at the moment that how can water be steam at 0 degrees Celsius? What you can do is simply take out ice from your refrigerator and see the fumes, see the gases being emitted from the ice. It is nothing but water vapor, and that is when you'll realize that water can actually exist as solid, liquid, as well as gas at 0 degrees Celsius at the triple point. Why it is happening? Because evaporation occurs. Evaporation because evaporation occurs at room temperature as well, and you can imagine the temperature, or what we call room temperature, varies according to geographical area. If you go to Siberia, the temperature will range from somewhere between -10 to -30, -40 degrees Celsius. And the thing is, there is a difference between evaporation and boiling that all of us had learned in primary classes, but we tend to forget. And what we forget is most crucial. So while, or if I draw a table, So understand that evaporation is a surface phenomenon, whereas boiling, if you take the opposite of what is a surface phenomenon, so surface phenomenon means evaporation process will only take place at the surface. That is why when we want to dry our clothes, we don't put them out in a crumpled state. We rather spread them as much as we can. This speeds up the process of evaporation because the more the surface area, the faster is the evaporation. So whereas this occurs only on the surface, boiling is a bulk phenomena. It occurs throughout the bulk of the liquid. Bulk phenomenon. So why this difference is because one of the first properties of matter, after the fact that matter is made up of tiny particles, is the fact that particles of matter are always in motion. So there are constant collisions between different particles. Now imagine this particle, the particle at the top, at the surface, gets a push, gets extra energy from a collision, and it tries to escape. But it is not like there are no molecules present above. In fact, there's a column 16-kilometer long, 16-kilometer tall column standing above all our heads, and that is what makes up the atmospheric pressure. Now here I would like to tell you the scale of pressure is Pascal or Newton per meter square, because pressure is defined as force per unit area. So these are two units that you must know. It can be asked in an exam. Pascal, after the scientist Blaise Pascal, or you can call it Newton. Unit of force and meter square, unit of area, and pressure is defined as force per unit area. So there is a column of 16-kilometer long air column right above it, and there are a lot of molecules, there's a lot of pressure, so this tries to escape but collides with another molecule and comes back down. In such a scenario, assume that if there was wind blowing, then this wind would increase, would speed up the process of evaporation, because after the collision, they would not be coming back. They would already, once they come up as gaseous particle, they will be eroded by the wind. So we say that wind, surface area, temperature, of course, if you increase the temperature, then the evaporation becomes faster. They are getting more energy from the sunlight as well, or the room temperature as well. They are able to absorb, and the evaporation speed increases. So surface area, temperature, wind, these are the factors that speed up the evaporation process. In boiling, what is so special is that boiling is a bulk phenomenon, and you would have observed while boiling water or when making tea that bubbles of air begin to escape. Now why is it happening? It is happening because particles present throughout the bulk of this liquid, throughout the bulk, that is, be it top, be it bottom, be it side, from all parts, the particles of matter are energetic enough. They have received enough energy after being provided heating, that particles from the entire bulk of the liquid, they are ready to escape. They all have enough energy that they can escape, and this is the primary difference between evaporation and boiling. But we must also know the definition of boiling. So boiling, while you might think that it is a very simple thing to recall, most students are not able to do so. And so boiling is not about water only, it is about liquids in general. And we say a liquid boils when. So there are two definitions. I would like you to know both. Boiling occurs when we say that vapor pressure exerted vapor pressure. I'll explain it soon. Exerted by the liquid equals the atmospheric pressure. Atmospheric pressure. This is one definition. The other thing we say is that it is the temperature boiling because it is point. So remember, this point exists on the thermometer, and therefore it is a temperature. It is a certain temperature which is a measure of heat. Temperature is a measure of heat. Just like we don't say that a distance, or we say that distance is measured in kilometers, speed is measured in kilometer per second or meter per second. Similarly, heat is measured in terms of temperature. The heat content of a body is measured by its temperature. So, vapor pressure exerted by the liquid equaling the atmospheric pressure, the pressure exerted by this 16, or if you are at the poles, 10-kilometer long column of air, because there is gravity pulling it down. So there is a pressure exerted by this. And when the vapor pressure, the pressure, so now, as you saw, that when they try to escape the liquid particles, let's say these are liquid particles, and when they try to escape, then they have a collision with particles of air. There are particles of air and they will try to push them down. So it is like having weights in the gym and trying to push it up. The more the weight, the more energy is needed. Remember this concept. It will be very easy. You will never miss a question regarding boiling and evaporation. Another definition is that the temperature at which adding any extra heat, adding further heat will not increase its temperature. That means adding any further heat will not increase its temperature, rather change its state. Change the state of the liquid. And we must not forget to mention at a given pressure, at the given atmospheric pressure. At the given atmospheric pressure, adding further heat. That means if we take the example of water and we are adding heat and its temperature so slowly increases, now it has reached 100 degrees Celsius. There is no extra pressure you are putting. It is at normal atmospheric sea level pressure. Then adding further heat will not increase the temperature from 100 to 101 degree or 102 degrees Celsius. Rather, the state of water will change from being liquid to being gaseous. That is the definition of boiling point. Vapor pressure exerted by the liquid becomes equal to atmospheric pressure. Either that point is reached, that is the boiling point, or the point of temperature after which adding further heat will lead to a change of state. and not an increase in temperature. That is known as boiling point. And it is for this reason that boiling point changes according to the pressure exerted. You would have seen, you would have commonly observed, if you have traveled to the mountains, then you must have seen that packets of chips, they are almost ready to burst. It seems like you put one pin and they will burst. They are extra inflated. They are inflated to their maximum capacity. So this happens because they were manufactured at the sea level. They were manufactured at the sea level, where pressure is this much, 16 kilometers of atmosphere pushing things down. But as you go up a mountain, let's say you've gone up 3000 meters or 3 kilometers, so the pressure will reduce. That means the weights that were attached in your gymming equipment, let's say, that has been reduced, and now you need to exert lesser energy. So the temperature at which vapor pressure becomes equal to this pressure will of course be less. So water might boil at 85 degrees Celsius because the pressure it has to encounter is already lesser compared to what it was at sea level. So the boiling point of water depends on two factors, not just temperature but also pressure, and it is equally applicable to all the liquids and all the gases. So state of matter, be it solid, liquid or gas, does not depend simply on temperature. There is another factor that causes the change of state, and that is pressure. We must never forget that both temperature and pressure lead to whatever state of matter there is. A common example that you would be knowing is that of dry ice. Dry ice is solid carbon dioxide, solid CO2, and this is manufactured by exerting a lot of pressure on carbon dioxide. It is called dry ice because this solid carbon dioxide being used in fog machines, in parties, you would have seen at parties, at plays, theaters, dance events, you commonly witness that fog is nothing but dry ice. And this dry ice, it does not change its state from solid to liquid and then to gas. No, this liquid phase is absent. That is why this word dry, it directly converts to gas. That is why it is called dry ice. The moment that pressure is released, it converts directly to gas. Also, I guess you must be aware of composition of atmosphere. That is, it has 78% nitrogen gas, 21% oxygen, very common knowledge, and 0.3% carbon dioxide, and rest are trace gases like trace amount. Trace gases like argon, helium, xenon. These are all inert gases, and this is what the composition of atmosphere is. Another very important terminology to know is Goldilocks zone. It is also related to water. So, Goldilocks zone is defined as that zone of temperature, of a star, because you will see the sun, then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. These are known as ice giants because they are extremely cold. The rays of sun, they are very feeble, extremely faint by the time they reach Uranus and Neptune, whereas Mercury and Venus are extremely hot. These places are extremely cold. the sweet spot of temperature, the Goldilocks zone, extends to Earth and Mars. So that zone of temperature of a star where water can exist as liquid, when water can exist, where water can exist as liquid naturally. That means without any artificial connivance, water can exist in liquid form. Why was the need to do this? Because scientists realized that water is very, very crucial for life to originate, because life originated in water. First came the amoeba, unicellular organism, then blue-green algae, first autotrophs, first cells that could produce food for themselves just by using sunlight and gases from the atmosphere. And because life originated in water, that is why we come up with this term Goldilocks zone, and this helps in astrobiological studies. We only take those planets in consideration when observing through telescopes which are in the habitable zone. Goldilocks zone, also known as the habitable zone, where habitation, where life is possible, habitable zone. So if tomorrow mankind were to become a starfaring or cosmonauts, people would be traveling interstellar distances, then the places we would choose as our home would be those that lie in the Goldilocks zone, because water can exist in its liquid form. Then there is the remaining part of this insulation. So you see that almost 45% of all the radiation is reflected back to the atmosphere already by molecules and clouds. Of the remaining 55% reaching Earth's surface, 4% is reflected. 4% of this 55% is reflected by surfaces like ice sheets, snow, and dry lands, light colored sandy soils. So this phenomenon is known as, it is this phenomenon that is known as albedo effect. Albedo effect. That means it is the capacity of an object or property of a material to reflect back light. If you take ice, it has a high albedo effect of 0.8. So out of 1, it reflects back 0.8% of all that radiation, and therefore temperature does not go so high. Whereas soil, dark colored soils, they would have an albedo of 0.18. That means 80% is absorbed, only 18%, 82% of heat or the radiation is absorbed, and only 18% is reflected back. This is called the albedo effect. Ice, light colored substances, light colored sand, yellow sand, they have high albedo. They reflect most of the radiation, whereas dark colored objects, they absorb. They absorb a lot of radiation, and their albedo is very less. So this was about the atmosphere and a little bit detail about terms related to water. Very important for your exam. Do keep them in mind, and remember to comment the names of 4 people, 4 IAF pilots who are going to be part of Gaganyaan. Thank you, and we will continue in the next class.